Hello students, myself K. Maninder Singh. Today I will be discussing operations on matrices. In operations of matrices, I will be discussing addition of matrices, then multiplication of matrix by a scalar, and difference and multiplication of two matrices. These are the things I am going to discuss. So let us consider a real life situation. One person called Fatima has two factories. She has two factories, factory A and factory B, where she makes sports shoes for boys and girls. These are the boys, this is girls, this is boys shoes, this is girls shoes. This is factory A, factory B, and of various price range 1, price range 2, price range 3. Here also price range 1, she makes in factory A 80 shoes for boys and 60 shoes for girls. In this way, this is so. Now she wants to know total production of shoes in each category. The production of boys sports shoe in category 1, total production is 80 plus 90, and category 1, total production of category 1 girls shoe is 60 plus 50. Next is 75 plus 70, then 65 plus 55 is the category 2 girls total production of girls shoe in category 2, and total boys shoe of category 3 is 90 plus 75, and for girls it is 85 plus 75. Now this situation can be represented by addition of these two, but if we call it, this one is matrix A and this one is matrix B, and this situation can be represented by addition of these two matrices, this matrix A plus matrix B, which is equal to this one. So formally we can say addition of matrices A and B matrix can be added if their order are same. Here it is a 3 by 3 rows and 2 columns, so it is a 3 by 2 matrix, 3 by 2 matrix. This is also 3 by 2 matrix. Two matrices of same order can be added, and they are added element wise, corresponding elements are added. So this is, if we say this is say A11 and say this is say B11, the A11 plus B11 is the A plus B first element, is this one. So if we take A is equal to Aij M by N matrix, and B then will be also, if I say Bij, this will be also M by N matrix, then A plus B will be Aij plus Bij. Element wise it will be added M by N. So if we add A11, first row first column element will be added with the first row first column element of the B. First row first column element of matrix A will be added with first row first column element of matrix B. First row second column element of matrix A will be added with first row second column of matrix B. In this way, matrix addition is performed. Now, let us define matrix multiplication. Multiplication of matrix by a scalar. Now, consider the situation. Now, suppose Fatima wants to double the capacity of production in factory A. Then how she will do? In that case, the production will become 80 into 2. In each category, she will increase. So 75 into 2, 65 into 2, 90 into 2, 85 into 2. So that means we have multiplied every element by the number to double the production of the factory A goods. Factory A goods, to double the production of factory A goods, what we have done? We have to multiply. To get the answer, we have to multiply each category production of each category by 2. So this is boys sports shoe category 1 is multiplied by 2. Boys sports shoe category 2 is also multiplied by 2. Boys shoe category 3 is also multiplied by 2. So girls shoe category 1 is also multiplied by 2. So we have got the multiplication of matrix by a scalar. This situation is represented by multiplication of matrix by a scalar. And what is that scalar? This is the scalar is here 2. So matrix multiplication of matrix by a scalar is defined like this. If we A is an matrix, say A is a matrix, say Aij, whose order is m by, and then if we multiply it by a scalar Ka, then each element of this matrix gets multiplied by K, element Ka. So this is the, so in this way matrix multiplication of matrix by a scalar is defined. Now difference of two matrices. Let us see what is the difference of two matrices. Difference of two matrices are defined in this. Let's say A is a matrix. A is a matrix this way: 1, 2, 3, minus 3, 2, 1, 0, 2, 3, something like this. And B is another matrix: 1, 1, 4, 3, 1, 2, 4, 3, 1. Something like this. These are the two matrices. Now, if we want to find the difference of these two matrices, simply we have to find out A minus B, and which is equal to the difference between the corresponding elements. That is, the first row first column element will subtract with first row first column element of B. That means 1 minus 1. Here next is 2 minus 1 first row second column minus first row second column. 2 minus 1, 3 minus 4 minus 3 minus 3, 2 minus 1, 1 minus 2, 0 minus 4, 2 minus 3, 3 minus 1. This is called difference of two matrices, which is defined in this way. This is equal to 0, 1, minus 1, minus 6, 1, minus 1, minus 4, minus 1. So this is the difference of two matrices A minus B. Obviously A minus B will not be equal to B minus A. And we can easily see some properties, their properties of addition of matrices. If A and B are two matrices, then obviously A plus B is equal to B plus A. B plus A plus B is equal to B plus A. We can check it very easily. If you added A plus B and B plus A, if you find out, both will be equal. So commutative law is called commutative law of matrix addition. Commutative law holds. Commutative law holds. Commutative law holds. A plus B is equal to B plus A, and associative also hold. A plus B plus C is also equal to A plus B plus C. Associative law holds good. In matrix, this is associative law. Associative law holds. And next is additive inverse. Let's hold for additive inverse exists. Additive inverse of A is minus A. If we multiply A by minus 1, then we get the additive inverse. Additive inverse of A is minus A, since A plus minus A is equal to 0. So that's why additive inverse of A is minus A. Additive inverse of A is minus A, and identity also exists. Identity element of matrix exists. Additive identity of matrix exists. Suppose A is a matrix. Suppose 1, 2, 3, 1, minus 2, 4. Then its additive identity will be, its order is 2 rows, 3 columns, 2 by 3. So additive identity will be 0 matrix. It is 0, 0, 0, 0, 0, 0. This is the additive identity of order 2 by 3. Order 2 by 3. The additive identity order must be equal to the order of A. So this is the additive identity of matrix A. So additive identity also exists. We have seen that additive identity exists. Additive inverse is also there. Matrix addition is commutative. Matrix addition is associative as well. And properties of scalar multiplication properties of multiplication of matrix by a scalar. Properties goes like this. If K is a scalar and A and B are two matrices, then K into A plus B equal to KA plus AB. K into A plus B is equal to K. So it distributes the addition of matrix. Scalar multiplication of scalar. Okay, if we multiply addition of two matrices by a scalar, it is same as multiplication of matrix by scalar plus multiplication of matrix by scalar. And K plus K is equal to KL, KA plus L10. This also holds good. So these are the properties of multiplication of matrix by a scalar, which can be easily verified. Now, very important idea is multiplication of matrices. So let us start with an example. Say A is equal to 1, 2, 3, 2, 1, 4. B is equal to 1, 2, 3, 2, 1, 1. If we multiply these two matrices, so for matrix multiplication to exist, first and foremost very important thing is to check whether it can be multiplied, whether A and B can be multiplied or not, whether we can find out A into B or not. That you have to check. So here you have to check first the order of matrix A is 2 by 3 matrix, 2 rows 3 columns, 2 rows 3 columns. So here number of column must be equal to the number of rows of the, here number of rows is 3 into 2. So this should be equal. This should be equal. Number of columns of the first matrix should be equal to number of columns of the second matrix. Then only we can multiply. Now how to multiply, that learn here now. What if we do? We have to multiply row into column. So first row, element 1 into 1 plus 2 into 3 plus 3 into 1. First row into first column. You see 1 into 1, 2 into 3, 3 into 1, and we will add. And for second element, again we will multiply this 1 into, with this column we will multiply. Now with this column we have multiplied first with the first row into first column, then first row into second column, then 1 into 2 plus 2 into 2 plus 3 into 1. This is what we have got. Then second row multiplication. For second row into first column. So 2 into 1 plus 1 into 3, 1 into 3 plus 4 into 1. Again second row into second column. 2 into 2 plus 1 into 2 plus 4 into 1. That's equal to 1 into 1 is 1 plus 2 into 3 is 6, 6 plus 3 is 9, 9 plus 1 is 10. 2, 4, 6, 6 plus 3, 9. 4, 3, 4 plus 3 is 7, 8, 9. Then 2, 3, 5 plus 4, 9. And 4, 8, 10. So this is the A into B equal to this one. Now let us see whether we can find out B into A also. We can find out B into A also here. B into A. A into B we have got, let me write it here, A into B is 10, 9, 9, 10. This is the A into B. Now let's find B into A. And we'll check whether it is commutative or not. A into B and B into A. find T into B into A is equal to 1. So B into A, we start with the first row into first column. First row into first column. When we take the first row of the B and first column of the A, that is equal to 1 into 1, 2 into 2 plus 2 into 2. First row into second column. 1 into 2 plus first row into second, first row into second, 1 into 2 and 2 into 1. Then first row into third column. 1 into 3 plus 2 into 4. Next, second row into first column. 3 into 1 plus 2 into 2. Then second row into second column. 3 into 2 plus 2 into 1. Then second row into third column. 3 into 3 plus 2 into 4. Then third row into first. Here third row into first column. 1 into 1 plus 1 into 2. Then 1 into 2 plus 1 into 1. Then 1 into 3 plus 1 into 4. So we have multiplied. Now let's find out the result. You see this is equal to 1 into 1 plus 4, it is 5. Then 2 plus 2, it is 4. Then 3 plus 8 is 11. 3 plus 4 is 7. 6 plus 2 is 8. 9 plus 8 is 17. Then 1 plus 2 is 3. 2 plus 1 is again 3. 3 plus 4 is 7. So in this way we get B into A is equal to this. So B into A, we see that this is a 3 by 3 matrix, whereas A into B is 2 by 2 matrix. So A by A into B is not necessarily is equal to B into A. So the matrix multiplication is obviously not commutative. Matrix multiplication is not commutative. So in this way we have multiplied two matrices. So formally we can say how to define the matrix multiplication. Formally we can define matrix multiplication in this way also. We can define, suppose let A is equal to one matrix is there, A is equal to Aij. It is a matrix M by N, and B is another matrix, so B J K, and its order must be n cross something, say n cross L. Then what is the element AB? So let C is equal to AB. So let's say that C is equal to, say, C is equal to AB. C is equal to AB. C is equal to AB is equal to C I K. C I K, and its order will be obviously M by L. This will be the order of the matrix AB. And how the elements are defined? C I K will be C I K. Each element will be C I K is equal to AI1 into B1K plus 2 into B 2K plus AI3 B3K plus plus AI N B N K. So this is what the CIK every element will look like this. How it comes, how it is coming. You see it is the ith row, kth column, ith row. So we have to take the ith row of the first matrix, ith row of the first matrix, that is AI is here. So I will, the ith row elements will look like this. Ith row elements will look like this: AI1, AI2, AI3, AIN. The ith row elements of A. Ith row elements of A will be AI1, AI2, AI3, AIN. So n elements will be there in the ith row, and kth, it will be get to get the ikth element, ith row kth column element of the product AB. So we have to multiply it with the kth column of B, kth column of B, which looks like something like this. Columns A, B, K, B1, K, B2, K, B3, K, Bn, K. So because here number of rows is n, so here see n rows are there. First row, second row, third row, and nth row, and it is column number is K, so column number is coming. Second element always, second this index always gives the column number. So second index is the for column number. So we are multiplying ith row of elements A into kth row of B, then we get this one. So in this way, matrix multiplication is defined. So again, let us take another example of matrix multiplication. Let us take one, two, three, 4. Here number of row is 2, number of row is 2, and number of column is also 2. Number of column must be equal to number of rows of this one. So 1, 1, 3, 1, 2, 2, 2, 1, 4, something like this. The 2, 2, 3, 4. So here you see number of column is 2, number of column is 2, number of column is 2. Here number of row, it is a 2 by 2 matrix. It is a 2 by 2 matrix, and this is a 2 by 4 matrix. So if this is A and this is B, then we can find out A into B, but the reverse we cannot find out. B into A we cannot find out, because here the number of column is 4. It is not 4, the number of row is not 2. So B into A we cannot find out, but obviously we can find out A into B. So let's find A into B. A into B is equal to what? A into, so it is first row into first, where this one is C11 element C11, so first row first column, first row into first column, first row into first column, first row into first column will multiply 1 into 1 plus 2 into 2, first row into second column 1 into 3 plus 2 into 2, and first row into third column 1 into 1 plus 2 into 3, then first row into fourth column 1 into 2 plus 2 into 4. Again second row, multiply second row into first column 3 into 1 plus 4 into 2, again 3 into 3 plus 4 into 2, again with third column 3 into 1 plus 4 into 3, below with the last column 3 into 2 plus 4 into 4. As a result, we get this is equal to 1 plus 4, which is equal to 5, 3 plus 4, it is equal to 7, 1 plus 6, again 7, 2 plus 8 is equal to 10, 3 plus 8, 11, 9 plus 8, 17, 3 plus 12, 15, then 6 plus 16 is equal to 22. So this is the answer. In this way, we find for multiplication of two matrices. So these are the various operation of matrices, that is, we have learned. It is addition of matrices, multiplication of matrices by a scalar, the difference of matrix, and finally we have learned multiplication of matrix as well. Thank you.